In this video, I'd like to talk about the math question of the day for February 6, 2023. And for this problem, we need to add this following expression here. And we can consider each of these rational expressions and we're adding them together. We call these rational because they are ratios of two polynomials. We have a 0-degree polynomial in this fraction in the numerator and a first-degree polynomial in the denominator. For this second fraction, we have a first-degree polynomial in the top and a first-degree polynomial in the denominator. So when adding rational expressions, we're just adding ratios of polynomials. But to answer a question like this, you do need to have a solid understanding of pre-algebra, namely fraction arithmetic, but you also need to have an understanding of variables and Algebra 1 and most of Algebra 2. So at this point, go ahead and pause the video and see if you can work through this on your own. Now at this point, assuming that you have attempted the problem and given it a couple minutes of effort, we can go through this together. And if you do have suggestions for future videos, please leave a comment down below and I can consider those. Now, to answer a question like this, we're adding these two fractions. We first need to remember how to add two fractions. Let's say we have 1/5 plus 1/6, and we need to add these together. And remember, when adding fractions, we need to find a common denominator. Now, we can look for the least common multiple of the two numbers, or we can just multiply them together and use that as a denominator. It won't always be the smallest, but it will always work. 5 times 6 is 30, so we can use 30 as our denominator. And in fact, in this case, this is the smallest denominator that we can use. But if, let's say, this was a 10, we could multiply them together and get 50, but 10 is a multiple of 5, so we could actually just use 10 in that case. But regardless, for this one we have 30, and so on this fraction 1/5, we multiplied top and bottom by 6. And for this one, we multiplied top and bottom by 5, so that this fraction becomes 6/30, and this becomes 5/30. And then we just add straight across. We have 11 of these 30ths as our final answer. But the key takeaway is that when finding that common denominator, we're not changing the value of the fraction because this is just multiplication by 1, which doesn't change anything. We are just rewriting this in a different sense so that we can actually add these numerators together. Now, when dealing with rational expressions, there are often several approaches. But if we want to find a common denominator, we can just take the denominators that we were given and multiply them together like we did here. So we can find a new denominator, and I'll put it in two separate fractions, but you can really leave it in one fraction, where our new denominator is now the product of each of these. We have x minus 4 multiplied by 2x plus 7 for both of these new fractions. And for the one on the left, we're multiplying the top and bottom by 2x plus 7. Since again, we're just multiplying by 1. We're not actually changing the value of anything. And for the second fraction, we're going to multiply the top and bottom by x minus 4. Again, we're not changing the value. This is just multiplying by 1. But it allows us to rewrite both of these fractions with that same denominator, this 2x plus 7 times by x minus 4. And at this point, we can just simplify everything. We have 3 multiplied by 2x plus 7, so we will distribute that. We get 6x plus 21. And over here, we'll distribute this x to each. We get x squared minus 4x. And now that they have the same denominator, we can actually add these together, so that our new denominator is just x minus 4 times by 2x plus 7. And if you want, you can multiply that out. But for our numerator, well, we have an x squared. That won't cancel out. We have 6x minus 4x, so that's plus 2x. And then we have plus 21. And we could try to factor and simplify, but it won't work. This top quadratic is not factorable. So this right here will be our fully simplified final answer.